Chapter 10 of The Structure of Scientific Revolutions by Kuhn, on revolutions as changes of worldview, is a relatively long, for Kuhn, for this book, a relatively long chapter and a subtle chapter. And I think the best I can hope to do here is read a few passages and give some preliminary observations. Let's do it, because this is really interesting stuff. Examining the record of past research from the vantage of contemporary historiography, the historian of science may be tempted to exclaim that when paradigms change, the world itself changes with them. Led by a new paradigm, scientists adopt new instruments and look at new places. Even more important, during revolution, scientists see new and different things when looking with familiar instruments in places they have looked before. It is rather as if the professional community had been suddenly transported to another planet, where familiar objects are seen in a different light and are joined by unfamiliar ones as well. Of course, nothing of quite that sort does occur. There is no geographical transplantation outside the laboratory. Everyday affairs usually continue as before. Nevertheless, paradigm changes do cause scientists to see the world of their research engagement differently. Insofar as their only recourse to that world is through what they see and do, we may want to say that after a revolution, scientists are responding to a different world. It is as elementary prototypes for these transformations of the scientist world that the familiar demonstrations of a switch in visual gestalt prove so suggestive. Okay, so it almost seems like, after a paradigm shift, scientists are working with a totally different world. Maybe not totally different, but a different world. It's like, with these changes in scientific paradigm, changes in ways of, changes in the theories that guide scientific research and interpretation of data, after these changes, scientists are living in a different world from the world they were living in before. And as an elementary prototype for this transformation, we have the psychological phenomenon of the visual gestalt switch. This means looking at the duck and then seeing a rabbit, or vice versa, that sort of thing. What were ducks in the scientist's world before the revolution are rabbits afterwards, says Kuhn. Transformations like these, though usually more gradual and almost always irreversible, are common concomitants of scientific training. Looking at a contour map, the student sees lines on paper, the cartographer a picture of a terrain. Looking at a bubble chamber photograph, the student sees confused and broken lines, the physicist a record of familiar subnuclear events. Only after a number of such transformations of vision does the student become an inhabitant of the scientist's world, seeing what the scientist sees and responding as the scientist does. The world that the student then enters is not, however, fixed once and for all by the nature of the environment on the one hand and of science on the other. Rather, it is determined jointly by the environment and the particular normal scientific tradition that the student has been trained to pursue. In becoming a scientist, a student of science undergoes something like the duck-rabbit transformation, or these days maybe we should say the laurel-Yanny transformation, or rabbit to duck, or Yanny to laurel. The student learns to interpret the same data differently and see something different. Not just same data, different commentary, same data, different interpretation, same data, different theory that's used to explain it, but through the data you actually see something. You don't just see lines on the page, you see the duck. You don't just see lines on the page, you see the rabbit. You don't just hear sounds coming out of your YouTube video, you hear laurel. You don't just hear sounds coming out of the YouTube video, you hear Yanny. And the process of becoming a scientist, being trained to be a scientist from just being a student, is largely the process of learning to actually see the thing where previously you just saw data you didn't understand. Instead of just confused lines, you learn to see a record of familiar subnuclear events. Instead of just confused lines, you see a picture of a terrain. Okay, so becoming a scientist means learning to interpret the data in such a way that you don't just interpret it, you actually see a particular thing that you didn't see before. And this is not simply a matter of the world or the environment plus science. It is the environment and the particular normal scientific tradition that the student has been trained to pursue. The training of a student of science to become a scientist who interprets the world according to the dominant paradigm in the field of science the student is being initiated into. This training trains the student to interpret the world according to that particular paradigm, and to see what that paradigm has us seeing. Therefore, at times of revolution, when the normal scientific tradition changes, the scientist's perception of his environment must be re-educated. In some familiar situations, he must learn to see a new gestalt. After he's done so, the world of his research will seem, here and there, incommensurable with the one he had inhabited before. That is another reason why schools guided by different paradigms are always slightly at cross purposes, etc., etc. He comments on other psychological things, like the one in chapter 6 where he talked about the perceptions of playing cards. Okay, surveying the rich experimental literature from which these examples are drawn makes one suspect that something like a paradigm is prerequisite to perception itself. And this sounds like Kant, actually. Well, I dare say this is in a lot of philosophers, but Kant is probably the single biggest one. Makes one suspect that something like a paradigm is prerequisite to perception itself. Like you can't even perceive anything without having a dominant theory about the world interpret your perceptions, or rather give you the perceptions, not just perception and then theory that interprets it. No, the theory affects the perception itself, so that it's because of the theory that you actually perceive what you perceive. Just as normally you look at these lines on a page in the duck-rabbit experiment, or maybe experiment's not their word. I guess it's sometimes an experiment, sometimes it's just people goofing around on the internet or something. Pull up the duck-rabbit on your phone or on your laptop or whatever, and you're not just seeing lines on the page, you're seeing the duck, or you're seeing the rabbit. It can take some work to actually see the lines on the page, for most of us anyway. Something like a paradigm is a prerequisite to perception itself, we might suspect. What a man sees depends both upon what he looks at and also upon his previous... What a man sees depends both upon what he looks at and also upon what his previous visual conceptual experience has taught him to see. In the absence of such training, there can only be, in William James' phrase, a bloomin' buzzin' confusion, etc., etc. The subject of a Gestalt demonstration knows that his perception is shifted because he can make it shift back and forth repeatedly while he holds the same book or piece of paper in his hands. Aware that nothing in his environment has changed, he directs his attention increasingly not to the figure, duck or rabbit, but to the lines on the paper he is looking at. Ultimately, he may even learn to see those lines without seeing either of the figures, and he may then say that it is these lines that he really sees, but that he sees them alternately as a duck and as a rabbit. After looking at the duck-rabbit picture long enough, you might be able to say, oh, I'm looking at these lines here, instead of I'm looking at a duck or I'm looking at a rabbit. You can normally switch back and forth between duck and rabbit, and eventually you may train yourself to not just see the duck or see the rabbit, but see the lines and know that they're being interpreted as a duck or interpreted as a rabbit, etc., etc. The effectiveness of the demonstration depends upon its being analyzable in this way. Unless there were an external standard with respect to which a switch of vision could be demonstrated, no conclusion about alternate perceptual possibilities could be drawn. Now, what Kuhn is doing here is drawing out the comparisons and also the contrasts between a scientific change in paradigm and these shifts in perception that are illustrated by a duck-rabbit experiment, or what's that other one? It was in the 7 Habits of Highly Effective People, I think, the old woman, young woman picture. And then Laurel Yanny, and, isn't there a gold dress, blue dress thing on the internet too? By the time this video hits YouTube, heaven knows, there might be something else that's been popular on social media of that nature. These are elementary prototypes for the sort of transformation of a scientist's world that Kuhn is talking about. These are prototypes for understanding how this works. These are not exactly the same thing. Okay, where was I? With scientific observation, however, the situation is exactly reversed. Here's one of those differences between these elementary prototypes and the scientific revolution. The scientist can have no recourse above or beyond what he sees with his eyes and instruments. With the duck-rabbit thing, you can see the duck, you can see the rabbit, and you can learn to just see the lines and realize that you're interpreting them in a certain way. The scientist doesn't have that option. The scientist doesn't have any recourse above or beyond what he sees with his eyes and instruments. If there were some higher authority by recourse to which his vision might be shown to have shifted, then that authority would itself become the source of his data, and the behavior of his vision would become a source of problems, etc. The period during which light was sometimes a wave and sometimes a particle was a period of crisis, a period when something was wrong. Some people were looking at light, the behavior of light, and saying, ah, it's a wave. Some people were looking at the behavior of light and saying, ah, it's a particle. And this crisis ended only with the development of wave mechanics and the realization that life was a self-consistent entity different from both waves and particles. In the sciences, therefore, perceptual switches accompany paradigm changes. We may not expect scientists to attest to these changes directly. To illustrate, looking at the moon. The convert to Copernicanism does not say, I used to see a planet, but now I see a satellite. That locution would imply a sense in which the Ptolemaic system had once been correct. But a scientist, you see, doesn't normally say the old paradigm was correct in a sense. That's not normal. Instead, a convert to the new astronomy says, I once took the moon to be, or saw the moon as a planet, but I was mistaken. Now that sort of statement does recur in the aftermath of scientific revolutions. Okay, so we don't expect scientists to testify directly to having been through the sort of experience a person experiences when he switches from hearing Laurel to hearing Yanny, or vice versa, or switches from seeing a duck to seeing a rabbit. Instead, the scientist says, I used to think there was a duck, but now I know there's a rabbit, or the nearest equivalent. In this particular illustration, where on the Ptolemaic system, the moon was thought to be a sort of planet, a kind of planet, a type of planet, a small planet, a large planet. Honestly, I don't remember if I ever knew exactly what sort of planet the Ptolemaic system would interpret the moon as. Anyway, it interpreted the moon as a planet, right? So now we see it as a satellite of a planet, Earth being a planet. And that's in the post-Copernican revolution astronomy. Okay, so this paradigm shift teaches the scientist not to say, I used to see a planet, but now I see a satellite. That's what the scientist would say if science were more like the duck-rabbit. If a scientific revolution were more like the shift between seeing a duck and seeing a rabbit, then you would say, I used to see a planet, now I see a satellite. No, instead the scientist says, I once mistakenly thought the moon was a planet. Now I know it's a satellite. It's not quite the same as the duck-rabbit thing, where you can switch back and forth. Actually, Kuhn has mentioned this. I think I mentioned this in an earlier video as well. Let us then return to the data and ask what sort of transformations in the scientist's world the historian who believes in such changes can discover. There's a nice, interesting example about the discovery of the planet Uranus. Let's skip it. Let's go to this one. This is one that works better in my head, I think, and I hope it works better for you. Like I've said before, reading the whole book is recommended. Reading his own examples to illustrate the ideas, I think, does help the ideas come together in your head a lot better than just reading the ideas. And after all, what's his method? His method is, let's pay attention to the history of science. So everything he's saying would be so much rubbish if it were not backed up with examples of how science historically has worked, according to his own criteria for a good method for thinking through what science is. Okay. Since remote antiquity, incidentally, if anyone is, so to speak, following along at home, in this edition I'm on page 118. This is the third edition of the University of Chicago. At the bottom of page 118, since remote antiquity, most people have seen one or another heavy body swinging back and forth on a string or chain until it finally comes to rest. This motion, I wish I had a string and I could swing a teacup or something. I guess this is not the worst illustration. A stone or something swinging back and forth on a string in some motion similar to this. Since ancient times, people have seen this, to the Aristotelians, who believed that a heavy body is moved by its own nature from a higher position to a state of natural rest in a lower one. The swinging body was simply falling with difficulty. Constrained by the chain, it could achieve rest at its low point only after a tortuous motion in a considerable time. Galileo, on the other hand, looking at the swinging body, saw a pendulum, a body that had almost succeeded in repeating the same motion over and over again ad infinitum. And seeing that much, Galileo observed other properties of the pendulum as well, and constructed many of the most significant and original parts of his new dynamics around them. The older Aristotelian science saw objects that have a natural tendency to proceed towards a state of rest as low as they can possibly go. And with a string constraining them, objects swinging on a chain, heavy objects swinging on a chain or a string, just do this motion until they stop at their closest they can get to their natural state of rest. Galileo sees something different. Galileo sees what you now see, sees a pendulum motion, sees objects repeating the same motion indefinitely, except that friction eventually slows them down and makes them stop. Galileo observed, using this information, a lot of other stuff that helped him construct a better physics. The most significant original parts of his new dynamics were largely constructed around his observations of the pendulum. From the properties of the pendulum, for example, Galileo derived his only full and sound arguments for the independence of weight and rate of fall, as well as for the relationship between vertical height and terminal velocity of motions down inclined planes. All these natural phenomena he saw differently from the way they'd been before. He saw them differently. Why did that shift of vision occur? Through Galileo's individual genius, of course. But note that genius does not here manifest itself in more accurate or objective observation of the swinging body. Descriptively, the Aristotelian perception is just as accurate. There's no external standard between the Aristotelian paradigm, and the Galilean paradigm, between the objects falling to the best of their ability because they have an innate tendency to proceed downwards, trying to achieve a state of rest, and the Galilean more or less perpetual motion, except they're obstructed by friction paradigm. Between these two paradigms, between any old paradigm and any new paradigm that's competing with it to replace it, since they are both, between any old paradigm and a new paradigm competing with it to replace it, since they are both dealing with the same experience and interpreting it in different ways, there's no third thing you can use to mediate the dispute. It's not like there's a more accurate or objective observation of the swinging body. Descriptively, the Aristotelian perception is just as accurate. It's just that one paradigm versus another paradigm. Now, I still want to caution, since plainly this means that science is not purely objective, we want to be careful in thinking through what it actually means with respect to the objectivity of science. It's not a statement that science is purely subjective. It's somewhere in between. But is it closer to the subjective side or to the objective side? That is something. That is one of the major questions you should keep in mind when interpreting Kuhn. I hope to get to a more solid answer as I proceed through this book. Reading this, it's hard to not think, oh, it's on the subjective side. It's mostly subjective. Science is mostly subjective according to Kuhn. Whereas reading in the last chapter, I was thinking, this seems like science is mostly objective. So why would there still be an objective element when he's saying that there's no more accurate or objective observation of the swinging body? Well, he says more accurate or more objective. To some large extent, they're both objective, objectively accurate interpretations. Descriptively, the Aristotelian perception is just as accurate. Both paradigms are correctly interpreting the data. Well, hang on, let me check it again. Descriptively, the Aristotelian perception is just as accurate. They are both giving they're both giving an equally accurate description of the data. Okay, so why does one paradigm win? Well, it's right here. It's even right here in this same passage. Why does one paradigm win? Because it's no less accurate as a description of the data, this particular experience of the swinging object, but it also, the Galilean paradigm, also gives you a useful way of interpreting the world more and better in the future that accounts for more facts. So now I'm looking at this and thinking, oh, it's clearly on the mostly objective side. It's not purely objective. Science is not a purely objective business, but it's much more objective than subjective. Etc., etc. Page 120. Do we, however, really need to describe what separates Galileo from Aristotle or Lavoisier from Priestley as a transformation of vision? Did these men really see different things when looking at the same sorts of objects? Is there any legitimate sense in which we can say that they pursued their research in different worlds? Can we really say there's different worlds here? Shouldn't we just say same world, different interpretations? Many readers will surely want to say that what changes with the paradigm is only the scientist's interpretation of observations, that themselves are fixed once and for all by the nature of the environment and the perceptual apparatus. On this view, Priestley and Lavoisier both saw oxygen, but they interpreted their observations differently. Aristotle and Galileo both saw pendulums, but they differed in their interpretations of what they both had seen. Okay, so shouldn't we just say same world, same facts, different interpretation? Why should we even toy with the language of scientists living in different worlds? A scientific revolution is a change of worldview. Or at any rate, if we're going to use a language like worldview, shouldn't we just say, there's the world, and one worldview is a different interpretation of the world from another worldview, but they're interpreting the same world with more or less accuracy. Well, Many readers will surely want to say this, and to say that what changes with the paradigm is only the scientist's interpretation of observations that themselves are fixed once and for all by the nature of the environment and of the perceptual apparatus. But remember what he said some pages back in this edition. That was on page 113. Drawing from psychological research of these gestalt shifts, duck rabbits, and so on. Drawing from internet experiments today with Laurel Yanny, red dress, gold dress, or whatever, blue dress, gold dress, blue dress, yellow dress, whatever the thing is. Surveying the rich experimental literature, etc., makes one suspect that something like a paradigm is a prerequisite to perception itself. What a man sees depends both upon what he looks at and also upon his paradigm for interpreting it. In other words, the perceptual apparatus is not exactly fixed. It's not just the nature of the environment and the perceptual apparatus that's always the same. No, the paradigm is part of the perceptual apparatus. I'm afraid that's how it works. Okay, so I think that's a Kuhnian commentary on this, but let's move through the text. Let's go down to this section of page 121. I really don't know if this is clear, but maybe it is. Though the world does not change with the change of paradigms, still in a certain strong sense of objectivity, the world still is what it is. Though the world does not change with the change of paradigms, the scientist afterward works in a different world. Nevertheless, I am convinced that we must learn to make sense of statements that at least resemble these. So we still have to figure this out. Still quite appropriate to say the world doesn't change, and to say scientists are working in different worlds after a paradigm change. We have to figure this out. What occurs during the scientific revolution is not fully reducible to a reinterpretation of individual and stable data. In the first place, the data are not unequivocally stable. Consequently, the data that scientists collect from these diverse objects are, as we shall shortly see, themselves different. The data are not a perfectly objective rendering of facts about the world, which then call for a scientific theoretical interpretation. No, the data themselves are filtered through a scientific paradigm. More important, the process by which either the individual or the community makes the transition from constrained fall to the pendulum or from dephlogisticated air to oxygen is not one that resembles interpretation. The change from one paradigm to another doesn't resemble a change in interpretation. It's something else. How could it do so? How could it just be a change in interpretation in the absence of fixed data for the scientist to interpret? Rather, being an interpreter, the scientist who embraces a new paradigm is like the man wearing inverted lenses. Confronting the same constellation of objects as before, and knowing that he does so, he nevertheless finds them transformed through in many of their details. None of these remarks is intended to indicate that scientists do not characteristically interpret observations and data. On the contrary, Galileo interpreted observations of the pendulum, Aristotle observations of falling stones, etc., but each of these interpretations presupposed a paradigm. Of course, scientists interpret data, but the interpretations all presume some paradigm, etc. That interpretive enterprise can only articulate a paradigm, not correct it. An interpretation articulates a paradigm. It doesn't correct a paradigm. Paradigms are not corrigible or correctable by normal science at all. Instead, as we've already seen, normal science ultimately leads only to the recognition of anomalies and to crises. These are terminated. Crises are ended, not by deliberation and interpretation, but by a relatively sudden and unstructured event like the Gestalt switch. Scientists then often speak of the scales falling from the eyes, or the lightning flash that inundates a previously obscure puzzle, enabling its components to be seen in a new way that for the first time permits its solution. And skipping to the end of the chapter, drawing from an illustration in chemistry, Kuhn says, the data themselves have changed. That is the last of the sentences in which we may want to say that after a revolution, a scientist works in a different world. So don't overestimate all this. Don't read into this more than he's saying. It's I almost want to say he's playing with the language. Playing is not the right word. Maybe experiment is better phrasing. He's experimenting with the language of a change in world. And he titled it Change in Worldview, somewhat more ambiguously. In some senses, we may want to say that after a revolution, scientists work in a different world. And while he's experimenting with this language, he's making it as clear as he knows how that there are senses in which nothing of the sort is true. The physical facts seem to be what they are quite independently of our interpretation or of our paradigms or of our collection of data. But for practical purposes, the world a scientist works with still is shaped by the paradigm, and there's no neutral data for the different competing paradigms to interpret, because the data themselves change when you change the paradigm. Okay, rewinding in this edition to pages 126 and 127, there's some interesting commentary on the idea that sensory experience is not fixed and neutral. Theories are not simply man-made interpretations of given data. Now, the epistemological viewpoint that has most often guided Western philosophy for 3 centuries dictates that we say that they are, according to Kuhn. That's what people like Descartes were trying to do. The modern Western epistemology was trying to tell us that there are facts, there are sensory experiences that are fixed and neutral, there are facts that have to be interpreted by theories, physical facts have to be interpreted by our theories. And that's how it works. And Kuhn's telling us that epistemology doesn't seem quite right. And it's got all these problems with modern psychology. 3 centuries after Descartes, our hope for such a pure observation language still depends exclusively upon a theory of perception and of the mind. And modern psychological experimentation is rapidly proliferating phenomena with which that theory can scarcely deal, like the duck, rabbit, and other things. Try it for yourself. Recent example I do like is Laurel Yanny. Find one of those videos on YouTube. Google Laurel Yanny shift, or Google shift from Laurel Yanny, or shift hear Laurel, then hear Yanny. Try that. That should work. Or hear Yanny, then hear Laurel. There may be different spellings of Yanny, because it's not all that clear exactly what we're hearing. At least, I don't hear it very clearly. If I listen for Yanny with an N, I might hear that. If I listen for Yammy with an M, I might hear that. Anyway, try Y-A-N-N-Y and Laurel, L-A-U-R-E-L. Hear Laurel, then hear Yanny. Type that into Google or something, and you should find something on YouTube where the famous or the infamous repeated sound is repeated, but it's sped up or slowed down, or the tone changes or the pitch changes or something, making it easier for someone who's stuck hearing Yanny Laurel to hear Laurel Yanny. Okay, so if you don't know what I'm talking about, there's this sound that's on the internet of some guy saying something, and some of us hear him saying it, and it sounds like he's saying Laurel. Others hear him saying this thing, and it sounds like he's saying Yanny. And there are YouTube videos that will help you move from hearing the one you hear to hearing the other one. So there's something about your ears or your brain or something else. There's something about how your mind works that interprets that data such that you're not just hearing sound waves, objective sound waves that are then interpreted by your mind. In some sense, that's still true. The sound waves are still there. They are what they are, quite independently of your perception. But you can't perceive them. All you can perceive is the sound Yanny or the sound Laurel, and sometimes maybe you can switch back and forth. Try switching back and forth using those YouTube videos to illustrate the idea Kuhn is talking about here. Of course, the physical facts are what they are, quite independently of us. In that sense, there's no change of world. But for practical purposes, the world the scientist is working with after a revolution is very different from the world he's working with before the revolution, because even the data are affected by the theory. Even the data, even the facts of what we're seeing and hearing are affected by our way of perceiving, and our way of perceiving includes, in science, the scientific paradigm theory that guides our interpretation of the data. It's been quite long enough. Maybe I'll see you on another video dealing with the next chapter of Kuhn. Thanks for watching.